Hi everyone, today we're going to talk about two different ways we can use the Pythagorean Theorem. So one way we can use the Pythagorean Theorem is to identify whether a triangle is a right triangle. And remember, a right triangle is a triangle that has a right angle, which is a 90-degree angle, and it looks like this. It has like a little box to show that it's a 90-degree angle. So essentially, if the Pythagorean theorem works for the three sides of a triangle, then it's a right triangle. But if it doesn't work, it means that it is not a right triangle. So a squared plus b squared should equal c squared. Now, one thing you need to watch out for is that c is always your largest value. So if you're given a list of the lengths of three sides, C is always going to be the largest one. Okay, let's see if we can determine whether or not these are right triangles. So for this first problem, we're given the lengths 7, 25, and 24. So remember, the one that we need to watch out for is this. So C is going to be 25, but 7 and 24, it doesn't matter which one is A and which one is B. So let's write the Pythagorean theorem, and let's substitute. So I'll replace A with 7, B with 24, and C with 25. So if this statement is true, it means that it is a right triangle. So here we have 49 plus 576 equals 625. So then we add here and we get 625 equals 625. So since this is a true statement, it means that yes, it is a right triangle. Okay, let's try this next one, 4, 8, and 9. So remember, 9 is going to be our C value. For 4 and 8, it doesn't matter which one is which. So a squared plus b squared equals c squared. Let's substitute. I'll replace a with 4, b with 8, and c with 9. So here we have 16 plus 64 equals 81. And if we add these up, we get 80 equals 81. So this is not a true statement. So that means that those three lengths do not make a right triangle. So not a right triangle. Okay, go ahead and pause the video and see if you can determine whether these make a right triangle and whether these make a right triangle. Okay, go ahead and check your answers below. The important thing is that you used 8 as your C value in the first example and 5 as your C value. So in the first example, you get a statement that is not true, so it's not a right triangle. In the second one, you get a statement that is true, so it is a right triangle. So another really good use of the Pythagorean theorem is finding the distance between 2 points. So let's say I'm given a point here and a point here, and I'm trying to find the distance between these 2 points. What you can do is you can actually make a right triangle in between them, and then you can count these distances. So 1, 2, 3, 4, 5, 6, 7. This has a length of 7. And then 1, 2, 3, 4. This has a length of 4. And then we can use the Pythagorean theorem to solve for our hypotenuse. So we can do a squared plus b squared equals c squared. So that's one way we can use the Pythagorean theorem. But of course, we're going to have to draw in our own right triangle. Now, you'll notice that down here we also have a new formula, this distance formula. So the distance formula is derived from the Pythagorean theorem, but we have it here so you don't have to rederive it every time. And this is a formula I would like you to memorize. So the distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So this x1, y1, x2, y2 would just come from these points. For instance, maybe we call this x1 y1, and we would call this x2, y2, and then we would substitute our values into the formula. So we're actually going to solve using the Pythagorean theorem and then using the formula, and we should get the same answer both ways. Okay, so let's find the distance between -3, 5 and 2, -1. So let's plot those 2 points first. So -3, 5 is up here, and 2, -1 is down here. So I want to find the distance from here to here. So remember, in order for us to do that, first we're going to need to make a right triangle, so you follow your grid, and then we count the distance. So this line, or this leg, has a distance 1, 2, 3, 4, 5, 6. And my other leg has a distance 1, 2, 3, 4, 5. And then this is our hypotenuse, so we'll call it C. So we can solve using the Pythagorean theorem. A squared plus b squared equals c squared. So we have 6 squared plus 5 squared equals c squared. 36 plus 25 equals c squared. 61 equals c squared, and then remember, the way you undo a square is by taking the square root of both sides. So we end up with c equals the square root of 61. Okay, so let's see if we can solve for this distance using the distance formula now. So remember, our distance formula, every time we're going to start by writing the formula, is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then I can look at my original points, and I'll label it x1, y1, x2, y2, just to make my substitution a little bit easier. So let's make our substitutions here. So x2 is 2, then I have minus x1, which is -3. And since I'm subtracting a negative, I'm going to turn it to +3. And then we square that. And then y2 is -1. And then we have minus y1, which is 5. Here, 2 plus 3 is 5. So we have 5 squared plus -6 squared. Because -1 minus 5 is -6. We know that 5 squared is 25. -6 squared is +36. And we end up with the same exact answer, square root of 61. So whether you make a right triangle and use the Pythagorean theorem, or you use the distance formula, you will end up with the same result. And you should know how to do this with both methods. Okay, go ahead and pause the video and give this one a try. So do it one time using the Pythagorean theorem and then one time using the distance formula. Okay, go ahead and check your answers here. So you can see below the graph I have the Pythagorean theorem. So 2 squared plus 5 squared equals c squared, and you end up with the square root of 29 as your distance. And here you can see I have the distance formula, and it's just substituting values and simplifying. So we have 5 minus 0 squared plus 2 minus 4 squared. 5 squared is 25, -2 squared is 4, and we get the same exact answer. All right, that is all for today's lesson. Thank you so much for watching.